So yesterday we discussed a little bit about integration, right? So let's proceed in the same token. So let's proceed about the integration. Okay, let's see what is an integration. Okay, so yesterday we saw that suppose we have this kind of a curve, right? This is the velocity versus time curve, and then the area under velocity versus time curve gives displacement, right? Area under the velocity versus time curve gives displacement. What is displacement? It's the final position x2, you can say, which is at time t2, minus initial position x1, which is at time t1. And how do we get that? So area is given by this integration, right? So integration of v dt, integration of v dt. What is v? V is velocity, right? So integration of v dt from initial time to final time. Okay, from initial time to final time. So now I said that this is the fundamental theorem of calculus. That means this theorem relates the derivatives and integrals. Okay, this theorem relates derivatives and integrals, right? Let's see how. So we know that velocity is given by, what is velocity? It is dx by dt, derivative of position with respect to time, right? And velocity is derivative of position with respect to time. And if you integrate velocity, what do you get? If you integrate velocity between two time limits, then you get position at final time minus position at initial time. That is, you get difference in position. Okay, so derivative of position gives velocity, and derivative of position gives velocity. Integration of velocity gives position, right? Derivative of position gives velocity, integration of velocity gives position. Okay, so derivative of first gives second, integration of second gives first. Is this in clear, everyone? Right? So this is an example. The position and velocity is an example. Okay, so we can apply this to anything. Suppose gx is derivative of f of x, then the integration of g of x, gx is derivative. Okay, if you integrate that derivative, then what will you get? You will get f of x, but you will get f of x between two limits, right? So that is, you get change in f of x. Okay, I'm sorry. So for an example, let's say f of x is sine x. So if you take derivative of sine x, what is derivative of sine x? It is cos x. Okay, so now if you integrate cos x, okay, integrate cos x dx from some x1 to x2, what should you get? You should get sine x. Okay, derivative of sine x gives cos x, so integration of cos x gives sine x. But there are these two limits, okay, x1 and x2. So x2 is called as the upper limit, x1 is known as lower limit. So how to write this then? So this is how we write it. Okay, then we substitute upper limit and the lower limit. So this is sine of x2 minus sine of x1. Okay, this thing is clear? Yes, no, everyone? Okay, very good. Then we can take some more examples. So again, derivative of tan x is secant square x, right? So f of x is suppose tan x, then its derivative, that is g of x, becomes what? Secant square x. So derivative of tan x, d by dx of tan x is secant square x, and therefore what will be integration of secant square x dx from x1 to x2? This integration gives what? Tan of x, but between those two limits. Yeah, very good. It will give tan of x, but between those two limits, x1 and x2, right? So that is tan of x2 minus tan of x1. Okay, so this is how we can solve for an integration. Okay, if we know that this function, this given function is derivative of something, then integration of this thing will be that thing. That thing means whose derivative this function is. Okay, so that's why the integration is known as an antiderivative or antiderivative, whatever you call it. Integration is an antiderivative or antiderivative. This thing is clear? Yes, no, everyone? All right, very good. So then, now integrations are of two types. Okay, the one that we saw, this is known as a definite integration. Okay, so if you know the limits of integration, the lower limit and the upper limit, then it is known as definite integration. Okay, so the integration whose limits are known is known as definite integration. The integration whose limits are unknown is known as indefinite integration. Okay, so what is an indefinite integration? So suppose you have f of x is equal to integral of g of x dx, but here the limits are not known, x1 and x2 is not known. So what do we do is we put a constant. Okay, this is known as constant of integration. Okay, for an example, g of x is cos of x. So if you integrate this, integration of cos of x dx is equal to, what is the integration? Tell me, will it be sin x or minus sin x?
Minus sin x.
Sin x.
It will be sin x, because cos x is derivative of sin x, right? Cos x is derivative of sin x. Yeah, good. That's why integration of cos will be sin x. Okay, so it will be sin x, but then you don't know the limits, so there will be a constant. Okay, you have to substitute a constant. Okay, so you can think of it this way. So x is suppose the upper limit, okay, and there is some lower limit, some constant is lower limit, that you can say is the initial condition. Okay, so it will be sine of upper limit minus sine of lower limit. Okay, sine of, let's say, c naught, and this minus sine c naught is equal to c. It's like that, there is not much difference. Okay, is this thing clear? Indefinite integral. Okay, good. All right, so then this is indefinite integration. Then next, let's see the power law of integration. Okay, let's see power law of integration, right? So we know power law of I'm sorry. Okay, so let's see power law of integration. So we know power law of derivatives. What is that? If you take derivative of x raised to n, what do you get? N multiplied by x raised to n minus 1. Okay, n multiplied by x raised to n minus 1. So now what do I want to do is, I want to find out, if I take integration of x raised to n, then what do I get? Okay, so if this is the power law of derivatives, then what can I say? That then if I take derivative of x raised to n plus 1, what will I get? I will get n plus 1 multiplied by x raised to n, right? N plus 1 multiplied by x raised to n I will get. Okay, this thing is clear. This n, the power comes in multiplication and the power is reduced by 1. Okay, so here the power is n plus 1, so this term will be multiplied by n plus 1 and power will be reduced by 1. So n plus 1 minus 1 is n, right? Then what I can do is I can take that n plus 1 on other side means this side, so it will become 1 by n plus 1 on the other side. So you have 1 by n plus 1 multiplied by derivative of this thing. Derivative of x raised to n plus 1 is equal to x raised to n. Okay, so I can take this 1 by n plus 1 inside here, right, because it is just a number, it's just a constant. Okay, so I can move it inside. So if I move it inside, what will I get? Derivative of this thing, x raised to n plus 1 divided by n plus 1, gives me x raised to n, and therefore if I integrate this thing, I should get this thing. Okay, so integration of x raised to n dx will give me what? This thing, which is x raised to n plus 1 divided by n plus 1. And if this is indefinite integral, then a constant will come. This thing is clear, everyone? Okay, so we sort of derived this formula. Integration of x raised to n dx is equal to what? X raised to n plus 1 divided by n plus 1, right? So we can take an example, 2 examples based on this. So using this formula, what will be the integration of x raised to 5 dx? Tell me. It is x raised to 5 plus 1, right, that is 6, divided by 5 plus 1, x raised to n plus 1 upon n plus 1 plus some constant. So x raised to 6, yeah, good, x raised to 6 divided by 6 plus c. Okay, similarly you can find out x raised to anything, 17 dx, right, why not? Okay, x raised to, let's say 7 dx will be equal to x raised to 7 plus 1, that is 8 divided by 8 plus c. Okay, so now this formula is applicable to every power. This formula is applicable to each power, to every power, to let's say any power, right, except for n equals to minus 1, then it's not applicable. So let me tell you why it is not applicable for n equal to minus 1, because we have one function called as log. Okay, natural log. So if you take log of x, its derivative is 1 by x. So d by dx of log of x is 1 by x, right? So that is x raised to minus 1. That means if you integrate this thing, if you integrate x raised to minus 1, okay, so n is equal to minus 1, what should you get? You should get log of x, right? So integration of 1 by x dx is equal to what? Log of x plus c. Okay, this thing is clear. So this formula is applicable always except for this thing, almost always I can say, except for n equal to minus 1. In that case it is equal to the integration is equal to log of x plus c. Right, this is simple. Okay, so in physics and specifically in NEET physics, we will have simple integrations. We won't have any complicated relations, complicated integrations. So let's see integration by substitution. Okay, so at max we will have integration by substitution. So what's that? So suppose we have integral of this form. Okay, integration is integral of f of ax plus b dx. Okay, so this is one type of this is one type of integration by substitution. There will be another type. So you have f of ax plus b dx. Then what will you do? You will substitute ax plus b as t. Okay, ax plus b as t. If I substitute, Then what do I get? If I take derivative of this thing, derivative of ax plus b, okay, so that will be dt by dx. If I take derivative of ax plus b with respect to x, that will be equal to derivative of t with respect to x. I am taking derivative of left hand side, right hand side. So if I take that derivative on this side, derivative is just equal to a, okay, and that is equal to dt by dx, okay. So I will write this thing as f of t because I have written ax plus b as t. Then what is dx? So from here we get the relation between dt and dx. So move dx on this side, a on this side, so a comes in denominator, so dx is equal to 1 upon a dt. So I will write this thing as f of t, and what is dx? It's 1 by a dt, and a is a constant, a is a number, okay. So I get this thing, integration of, so this integration, same integration, is integration of f of t dt by a. You can move a outside, then you get 1 by a integration of f of t dt, and that's why, now what is this integration? So if this f of t is derivative of something, okay, so if t capital F by dt is equal to f of t, then integration of f of t will give you this capital F, right? So integration of f of t gives you capital F of t plus c, okay. You can do that. So integration of this thing will be capital F plus some constant, but this thing will be divided by a. This thing is clear? Yes, no? All right. So for an example, you have I equal to cos of 3x plus 9 dx, right? So what will be integration of this thing? So this rule says that just take integration thinking as if there is this bracket only, okay. This is cos is function of this bracket, so what will be its integration? So cos is derivative of sine, means integration of cos will give you sine. So integration will be equal to sine of 3x plus 9, but then you have to divide by the derivative of this bracket, okay. So that is 3, and there will be some constant. This thing is clear? Yes, no? Okay, so the a that we are talking about here is just equal to what? We just have to divide by that a, okay, if integration is of this form. Then for an example, this thing I is equal to integration of sine of 5x plus 8. So what will be its integration? Cos or minus cos?
Minus cos.
Good, it will be minus cos, okay, because you know that if you take derivative of cos, it is minus sine, okay. So I can write this as minus of minus sine of 5x plus 8 dx, okay. I am multiplying with minus minus, so minus minus is plus, right? So derivative of cos is minus sine, right? D by dx of cos is minus sine, therefore integration of minus sine would be cos. So integration of this minus sign would be cos, okay, but you have this negative sign here, right? Therefore it will be minus. Then integration of I'm sorry, cos this thing, integration of this thing will be cos of 5x plus 8, but then you have to divide by 5, and then there will be a constant, okay, constant of integration, right? Then you have I equal to secant square 3x plus 3x minus 7. Good, secant square of 3x minus 7, then you integrate this. Now you tell me.
Tan.
It will be tan, okay, but it will be tan of this bracket, right? that is tan of 3x minus 7 divided by 3.
3.
Good. Plus c. Right? So this is very simple. Okay. So if you have some function of the form ax plus b, okay, some function of ax plus b, then its integration would be just integration of that function. If it is sine, the integration would be minus cos. If it is cos, integration is minus sine, okay, etc. And then you divide by derivative of that ax plus b, which is just a, right? So this type of integral is very simple, right? So we can solve n number of these. So we just saw this one, integration of 1 by x dx, okay. So now you tell me, what about this thing? So integration of this thing would be equal to what? 4x plus 9 raised to 3 upon 3, but then we have to divide by derivative of this bracket. So derivative of this bracket is just 4, so divide by 4, okay, plus there will be some constant, right? So this is simple. Yes, no? Okay, good. Then you have for an example, what was that integral? Integration of 1 by 3x minus 7 dx, okay, something like this. So you integrate this, tell me. So you know that integration of 1 by x dx is equal to log x plus c, right? We know this thing. Then what will be integration of this thing? It will be log of 3x minus 7, right? This term, yeah, but then you have to divide by the derivative of this bracket, yeah, 1 by 3, okay. So it will be 1 by 3 multiplied by log of this term, and then there will be a constant, okay. So then that means if you have any integral of the form ax plus b, okay, function of ax plus b, you can solve it very easily, right? Just take the integration of that function and divide by a, that's it, okay. That's the solution, right? Then next is integration by substitution, okay. That thing also was integration by substitution, but more or less we can do it by inspection, right? So next, suppose you have integrals of the form, so integration of f of gx dot g dash x dx, okay. What is g dash x? G dash x is derivative of g with respect to x, okay. So you have function of f is function of g of x, right? And derivative of this function g of x is sitting there in multiplication, okay, right? Okay, it can be any function. So or there is another type, I is equal to, suppose f of x raised to n, right, multiplied by the derivative of f of x is sitting there in multiplication, okay. Or it's 1 by f of x, because the power formula will not be applicable when n is equal to minus 1. So 1 upon f of x, okay, the integral of 1 upon f of x dx, but in multiplication you have f dash of x. So this kind of an integral. So then what we'll do is we'll substitute this g of x or f of x, right, equal to t, okay. Then if you take derivative of this thing, what will happen? It will be equal to dt by dx, okay. And therefore if you move this dx on that side, then the matter simplifies. Then you get g dash of x dx is equal to dt, right? So then it will just become f of t, and this thing is dt, and the integral will be very simple, Okay, this is sorry, is this thing clear? Okay, good. So let's try this. So you have x square plus 3 cube multiplied by 2x dx. Okay, so what will be integration of this thing? So you have x square plus 3 cube multiplied by 2x dx. I'm sorry. Okay, so here you just put f is equal to x square plus 3 cube, right? This is f of some t, suppose, right? That means what you are substituting is x square plus 3 is equal to t. Okay, x square plus 3 is equal to t. Then if you take its derivative of this thing, x square plus 3 will be equal to dt by dx. Okay, so what is derivative of this thing? It's 2x. So you have 2x equals to dt by dx, and therefore if you move this dx on this side, what do you get? Good, 2x. So dt is equal to 2x dx. Okay, so you see here 2x dx is already there. That means if you substitute t for this, okay, just substitute t for that, then your integral is simplified. So it is integral of t raised to 3, and this thing is what? This thing is just dt. Okay, t raised to 3 dt, and that's equal to, tell me, it is just t raised to 4 by 4 plus c, right? And then you can substitute your t. So t is what? X square plus 3. Put that. So it is x square plus 3 raised to 4 divided by 4 plus c. So that's the answer. Is this format clear? Yes, no?
Yes, sir.
Okay, everyone? Good. Let's see some examples based upon this thing. So you have very lengthy integration, x cube plus 3x square plus 9 cube, but its derivative is there, sitting there in multiplication. Then what will be the solution of this? Okay, if you take derivative of this thing, you get 3x square plus 6x, right? I have written it that way only. So what do you get? I equals to, it will be just integration of this thing. Okay, so it will be x cube plus 3x square plus 9 raised to 4 divided by 4 plus c, right? This is clear. Okay, now you can skip these steps. If you identify that this thing is derivative of this thing, what will be its integral? What will be integral of this thing? Just integration of this bracket plus c. Okay, derivative of bracket is sitting there in multiplication. Everyone, this is clear? Yes, no? Alright, good. Then let's take integration of cot x. Okay, so it is of the same form. So I can write this thing as, this is integration of cos x by sin x dx. Oh, I wrote dt here, should be dx. This question? Alright, no problem. See, you have derivative of this thing in multiplication. So what you can do is, you can substitute for this. Okay, this thing you can say is t. Let's say t is equal to x cube plus 3x square plus 9. Okay, so this thing will be t raised to 3, right? If you take its derivative, dt by dx will be equal to what? It will be derivative of this thing. So that is 3 times x square plus 6x. Okay, derivative of 9 is 0, right? Move that dx on that side. So you get dt is equal to 3x square plus 6x dx, and you see that this thing is there. Okay, so what is your integration then? I is equal to, it's just integration of, this bracket is t, sorry, yeah, same bracket, this bracket is t. Okay, so it is t cube, and this whole thing is dt, t cube dt. Then you know what is integration of t cube dt, right? It is just t raised to 4 by 4. So therefore you
Yes.
have integration t raised to 4 by 4 plus c, and then you put what is t. Okay, that is x cube plus 3x square plus 9. Okay, that thing raised to 4. Okay, so this is clear? Yes, no?
Yes, sir.
Okay, good. All right, let's see next one. Next is integration of cot of x. Okay, so cot of x can be written as what? Cos x divided by sin x. So take its integral. So what can I do is, I can say t is equal to sin x. Then if you take its derivative, dt by dx is equal to what? Cos of x. Move the dx on that side. So you get dt equals to cos x dx, and it's there. Okay, so that's why. What will be the integration? Tell me. Anyone? Yes, anyone? Log of sin x. Good. So it will be log of sin x, right? So you have integration of dt, right? This thing is dt by t. So that is just integration. This integration is just log t plus c, and what is t? T is sin x. Okay, therefore this is log of sin x plus c, right? Okay, good. Then similarly you have tan of x. So can somebody tell me what will be its integral? So tan x can be written as what? Sin x divided by cos of x dx. Okay, put t equal to cos x, take its derivative. So dt by dx is minus sin x, but you don't have minus sin x, you have sin x. That means you have to multiply by negative sign. Okay, so dt is equal to minus sin x dx, and therefore this thing can be written as sin x dx can be written as minus of dt, right? You put that. Okay, so you get I is equal to integral of minus dt by t plus c. Minus sign you can take outside, so it is just integral minus of integral of dt by t, and that is log of t, and therefore it's equal to minus what? Your t was cos of x minus log of cos x plus c, right? Very simple. Okay, then tell me about this one fast. See, you have this function and its derivative is there in the numerator. Is it there? Okay, so put t equals to x cube minus 9. What will be its derivative? So dt by dx is equal to 3x square, right? You don't have 3x square, you have just x square. So what can you do is move this dx on this side, then you get 1 by 3 dt will be equal to x square dx. Okay, so in place of dt you are having here 1 by 3 dt, right? So this x square dx becomes what? 1 by 3 dt. So therefore your integral will become I is equal to integral of 1 by 3 dt by t. 1 by 3 you can move outside, it's 1/3 of log of t plus c, and that is equal to what? T is equal to x cube minus 9, so therefore it is 1/3 of log of x cube minus 9 plus c. This is the integral, right? This thing is clear, everyone? Okay, so then now the difficulty level of integration will be up to this much only, and there will be few specific integrations that we'll see whenever they come. Okay, all right, so this is integration, and now so we are almost done with the math that we require. Okay, this is the math that we require. Then some more maths will come, scalars and vectors, that we'll see later. When we start with motion in a plane, we'll see scalars and vectors then. Okay, all right.